All right, this is the second part of the midterm for Math 142 online. Number 6. Number 6, find the angle whose tangent is positive and whose sine is equal to a half. Whose tangent is positive. So I'm looking for an angle whose tangent is positive. So I must be looking at tangent is positive. Tangent is what? It's like y divided by x. So if y and x are both positive, then yes, I've got an angle here, perhaps, that would have a positive tangent. Also, y divided by x, if the y-coordinate is negative and the x-coordinate is negative, then I've got an angle clear over here that the tangent is positive, right? But the sine is equal to negative a half. It can't be this angle here because, you know, negative a half, the hypotenuse we're always taking as positive, and so if the y is positive and the hypotenuse is positive, then that's positive, it's not negative. So here, perhaps this third quadrant angle with the sine being negative and the hypotenuse being positive, and then you could get a sine equal to minus a half. So this is minus 1 and 2. Right? And so the question is, can you find that angle? What is that angle that's right here? Now, granted, there may be more than one answer. I took any correct answer. Some people gave it me in radians, some in degrees, doesn't matter. Some people gave me the positive angle going this way, or some people gave me the negative angle going that way. I don't care, as long as you figure out what that angle is. Okay. If you just use your calculator and said, sine inverse of minus a half, it's not going to give you this angle, right? And you got to know how to compensate for that. Sine inverse would be giving you this angle. Sine inverse of minus a half actually gives you this angle, because this also has a minus 1 over 2 down there. But you got to compensate to get over here. But this is a nice angle, and you should be able to just figure out what it is. Okay. Number 7. Find the length of side A. Yeah, there are a couple ways people did this. Some people figured out that this angle must be, 53 degrees, and they used the law of sines on this thing, which seems to be a bit overkill because it's a right triangle. It works, but, you know, on this thing, 37 degrees, that side, you know, it looks like tangent. Tangent of 37 degrees is 15 over A. Solve for A. Multiply by A. A tan 37 degrees equals 15. Divide 8. Whoops, I don't think I was supposed to solve this problem for you, but okay. There you got A, right? Just with a right triangle, you don't need the law of sines because you got these direct relationships. But it would be okay to use the law of sines as well. This one, what's the radius of a circle if the central angle of 30 degrees intends an arc of length 7? So I've got a circle, I've got a central angle of about 30 degrees. This is 7. Notice that just in drawing that, it looks to me like, you know, this length of 7 is certainly longer than that. So if you do this problem and you end up with, the radius is bigger than the 7, right? So I had a lot of people say, oh, arc length, radius, angle, right? You got this angle in here. This is 30 degrees. So they know the arc length is the radius times the angle, and they say, oh, this is 7, this is 30, and they divide. So r is 7 divided by 30, and they get this tiny little number. Right? 7 divided by 30 is small. It's like less than 1. It's like less than a half. It's really, really, really small. A 0.24 or something like that. I don't know. It's small. It's like, how the heck could this be 0.2 something if that length there is 7? I mean, do a reality check. Look at your answer. What went wrong? What went wrong is this angle can't be 30. The thing is, this relationship here only works if theta is in radians. So you got to make the conversion to radians first. Okay. Yeah. So anyway, there's number 8. I didn't finish it for you, but I give you a good idea where you're going on it. Number 9. Yeah. First of all, it says label. It says do clearly indicate this stuff. Label your axes. Some people, it's clear. They type this into their calculator. They got a graph and they sketch something kind of squiggly on here, not paying any attention to how high it actually goes and how low it actually goes. It looked to me like you just typed it into your calculator. It's like you didn't get full credit for it. I want to see that you know what this looks like. Okay. Now, several things. This right here is the vertical shift. This right here is not the horizontal shift, but if you factor a 2 out of that and say 2 times x minus pi over 6, then this right here is the vertical shift, right? So it shifts over pi over 6 to the right. It shifts up 3. So what normally would be the origin is up 3 and over pi over 6. Now I haven't labeled my axes yet, so I don't know. In this direction, I'm going to say 1, 2, 3, 4, 5, 6, right? So up 3 would be up here. Pi over 6, I don't know. How far over is it? I know a lot of people do this and say that this was pi over 6. Right? The labeling your axis is so important because I have a lot of people then tell me here that this 2 is going to do something with the period, that the period is going to be 2 pi divided by that 2. Oops, I'm off the top of the page here, sorry. 2 pi divided by that 2, which would be pi. Correct. The period is pi. And yet, then they would draw something that didn't have period pi, or I couldn't tell it had period pi because they didn't label their axes. Then, even when people do label their axes, it's like, if this is pi over 6, from here to there, that distance right there is pi over 6. What is this one? What is that one? Right? What is that one? What is that one? The thing is, each time you move over that much, it's the same increment. It's pi over 6. So if this was 1 pi over 6, this is 2 pi over 6. This is 3 pi over 6. Notice 3 pi over 6, 3 over 6 reduces to 1 over 2. This is pi over 2 right here. I saw one person label this as pi over 4. It's like, if that's pi over 6, there's no way this could be pi over 4. It's 3 pi over 6s. This is 4 pi over 6s, 5 pi over 6s, 6 pi over 6s. 6 pi over 6s is pi right there. Okay, that the labeling of the axis needs to be consistent. That you tell me how big, one is. It's like in this direction. If I said this is 1, and then this is 5, and then this is 10, and then this is 20, it's like, what? If this gap is 1, then every gap is 1 in that direction. If this gap is pi over 6, then every gap is pi over 6. Get those axes labeled consistently. Then it allows you to say, okay, I got a sine curve that's shifted over pi over 6 and up 3. So rather than starting here, it's going to start there. This negative 2, the amplitude is 2, right? The amplitude equals 2, and it's upside down. How do I know it's upside down? Because that minus sign flips it upside down. So it's starting here and it goes upside down. The period is pi. So from here, if I move over pi, which is 6 pi over 6s, 1, 2, 3, 4, 5, 6, that should be my ending point. The middle would be right in the middle. Halfway in between there and there would be the 1/4 point, and it starts off going down. So it comes down an amplitude of 2. Right, amplitude of 2. And over here it's a 3/4 point, it goes up an amplitude of 2. So it's going between 1 and 5. There's one cycle. If I want to continue it, I just do this. Boom. I can see the gap here is 3. So 1, 2, 3 pi over 6s. 1, 2, 3 pi over 6s. 1, 2, 3 pi over 6. And then whoops, that one was too high. It should be right here. Down 2, up 2, down 2, and there you go. Right? Just to say, please excuse my drawing abilities. Well, if your drawing abilities aren't very good, then plot a few more points. I mean, that's what I have to do. My drawing abilities are crappy, but I get enough points drawn in there that I get a pretty good idea of what the graph looks like, right? I mark those midpoints, I mark the highs and the lows, and then I can get a pretty good drawing in between, right? There's that, number 9. Number 10, find an equation. First of all, Some of you have this thing circled or underlined, an equation, because you didn't give me an equation. You gave me an expression that doesn't have an equal sign in it. That's not an equation. An equation has to have an equal sign in it. And to say the graph of an the equation of a graph, you're telling me a relationship between x and y. So if your equation doesn't have any y's in it, then you're not giving me a relationship between x and y. So the answer's got to look like y equals something, right? If you left off the y equals, that was -1. Then this is either a sine or a cosine or an upside down sine or upside down cosine. I accepted any one of them. You got to figure out what what all the pieces are. First of all, I see that it's not centered along the y-axis because it only goes up to 3 and it goes down to -5. So the center is here, shifted down 1. Right? So already I can see the shift is down 1. Because that's where the center line is. But then from there I can see from the center to the top or from the center to the bottom, how far is that? The amplitude seems to be 4, right? Not 8. Yes, it's 8 all the way from the bottom to the top, but the amplitude is measuring like up here, right? This 2 up here was the distance from the center line up or from the center line down. The amplitude is not measuring the total, it's just measuring half. Okay. So down here, the amplitude there is 4. What's the period? Well, you can count either from peak to peak or sort of midpoint here to midpoint there. I usually see peak to peak the best here. So from here I'm moving over 1, 2, 3, 4, 5, 6, 7, 8, and it seems like every unit in this direction is just 1. Right from here it's 1, 2, 3, 4. Yeah, that's labeled 5, 6, 7, 8, 9, 10. Okay, so each time I move over 1 square, that's 1. So there was 8 going across there. So the period is 8. Now remember up here, this 2 wasn't the period. The period was 2 pi divided by this thing. So the number that I'm going to use there is going to be 2 pi divided by 8 is the b that gets used in there. Right? Now, what shift is it? Well, the shift depends on, do you think it's a sine curve? So maybe the origin got shifted over to here, in which case that would be 3 to the right. Do you think it's an upside down sine curve, and then it would be 1 to the left? Do you think it looks like a cosine curve, or maybe the origin got shifted here and your cosine curve is starting up at the top, or even over here, right? Is it an upside down cosine curve? In which case maybe the origin was shifted there and the cosine curve is starting down at the bottom. Okay. Either way, whichever one you think it is, you're going to have an x minus that shift inside parentheses, then times this 2 pi over 8, and all of that is inside either the sine or the cosine, whichever one you think it is. There's going to be some amplitude out in front, plus or minus, depending on whether you thought it was right side up or upside down, and then you're going to have plus that vertical shift of, well, -1, right? And it's y equals, right? Put all that together for me. I just said it out loud. Explain how you look at the graph, find the pieces, put them into the equation here. Okay. Well, I'm going to have to